Hello friends, a very warm welcome to all of you. So guys, I know GATE exam is very near and it's like 2nd Jan. तो सिविल वालों के लिए almost 31 days, मतलब slightly more than 31 days, एक महीना ही है उनके पास. And mechanical guys have like 1 week more. So now is the high time to focus a lot on revision. अब तो आपको बिल्कुल भी थोड़ा सा भी time waste नहीं करना है. You have to like मतलब 95% of your time must go in revision and only 5% time should go in studying extra. समझ रहे हैं ना आप? Revision is the key to success. And I think I have started like 1 minute earlier. But anyways, I know your time is very crucial and let's start with the topic for today. So any student who is going to watch the video for the first time, for them, the information is that every day we are taking one concept. So for that concept, we are doing a question. So we will do the concepts order wise. And today we have the concept of stability. So tomorrow the concept will be liquids in relative equilibrium. So I will not take more than 50 minutes or 1 hour like I did in the last class, so that you can focus on your revision. Okay? So ultimate aim is that fluid mechanics you can revise with me. So today's concept is stability. So let me give you a question for that. So what it says, that let us suppose there is a cube. Okay, so there is a cube 1 by 1 meter. So each side is 1 meters. That's why I think we call it as cube. Otherwise I could have called it as cuboid also. So each side of the cube is 1 meter. And it says the lower portion of the cube, which is a cuboid. So this lower portion of the cube, which is a cuboid, which has a height of 1 by 4 meters. So this portion, it is made of some material which has a density of 15,000 kg per meter cube. Okay, this is the density of the lower portion of the cube. And for the upper portion of the cube, the density is 500 kg per meter cube. So obviously this portion is going to be 3 by 4 meters. Okay. Now what they are saying, let us drop this cube in an oil whose density is 800 kg per meter cube. So density of the oil is 800 kg per meter cube. So we will solve this question in steps. Let us solve this question in steps. So the very first part of the question is, whether the object will float or sink. The first part of the question is whether the object will float or sink. And since students have not joined, so I think without wasting any time, I will continue with the solution of the same. So guys, obviously you can say, sir, this is a body of non-uniform density. So whenever we take an example of submarine, so submarine is made of steel and steel has a density much greater than density of water. So steel is like 7,000 kg per meter cube up to 8,000 kg per meter cube. And water is like only 1000 kg per meter cube. So steel has a much higher density as compared to water. So I say that a submarine stays at one place within the water. It never sinks. And there is no propulsion system for that. So you guys tell me that, sir, from inside the submarine is hollow and it is filled with air. As a result, the submarine is a body of non-uniform density. So when you consider the average density of submarine, that is equal to the density of water. That's why the submarine remains at one place. So whenever we are talking of whether the body will float or the body will sink, we have to check the average density of the body. What we have to check? We have to check the average density of the body, right? So the question is, how much is the average density? So if the average density of body is greater than density of oil, the body will sink. If the average density of body is less than density of oil, the body will float. So the very first part is to find out the average density of the body. So let us solve the first part. Okay, actually there are multiple parts. In the next part, I will give a vertical displacement and I will ask you whether the body is stable or not. If the body is stable, what will be the frequency of oscillation? Then I will ask you, if we give a rotational displacement, whether the body is stable or not. Okay, so these things I am going to ask. Now, particularly in IES, a question of rotational displacement can also come. So I will not ask you the question over here because it is not a part of GATE exam, but I will let you know the formula for the same. Okay. Now check, guys. So what we have a cube. So I am showing a 2D figure only. I am looking at the cube from the front and the total height of the cube is 1 meter. Now, how do you write down the average density of body? I think average density of body is written as total mass of the body divided by total volume of the body. Now, this entire body is divided into two parts. So, let me call the lower portion as 1 and upper portion as 2. So, what you will say? You will say the total mass of the body is mass of part 1 plus mass of part 2 divided by volume of part 1 plus volume of part 2. है ना? So total mass will be mass of the components, sum of mass of components. Total volume will be sum of volume of components, right? Okay. Now please check. I think you can also say when you write down the mass of part 1, portion 1, you can also say density of portion 1 multiplied by volume of portion 1. Plus density of portion 2 multiplied by volume of portion 2. So this will be divided by volume of portion 1 by volume of portion 2. We just have to solve this and we will get our answer. Now check for yourself. Check for yourself. How much will be the volume of portion 1? I think this is 1 meter. This is 1 meter. This is 1 meter. And the height of portion 1 is 1 by 4 meters. So obviously you will say that when we are talking of portion 1, it has a volume. When we are talking of portion 1, its volume is equal to 1 into 1 into 1 by 4. So that will become 1 by 4 meter cube, right? And similarly, when we talk of the volume of portion 2, it will be 1 by 1 by 1 by 1 by 3 by 4. That will be 3 by 4 meter cube. So these are the volumes. Density values we already know. So rho 1, that is 1500 kg per meter cube, and rho 2 is 500 kg per meter cube. So when you will put the values, rho average is equal to 1500 into 1 by 4 plus 500 into 3 by 4 divided by total volume. Total volume is nothing but the entire volume of the cube. That is 1 meter cube. So what we are doing, we are finding out the average density of solid body. Now I think this is also 1500. So 1500 by 4 plus 1500 by 4 divided by 1. That is nothing but 3000 by 4. So when you talk of rho average, this will become 3000 by 4. Now 1500 by 2. So that is 750. So average density of the body is 750 kg per meter cube. What is the density of the liquid? The density of liquid is 800 kg per meter cube. So obviously density of liquid is more than density of body. So body will float. Body is going to float, right? Why? Because the average density of the body is less than density of the liquid. Body is going to float. So for the very first question, the body is going to float. So our answer is flotation condition, floating. Now the next part of the same question is कि भैया, how much is the height of body inside the liquid? Height of body inside the liquid. Height of body inside liquid. Height of body inside liquid. Okay. So I think what you will say, sir, body is in flotation condition. So obviously the body is in equilibrium. Therefore, the net force on the body is equal to the weight of the body. So when we will solve the second part, we will simply say the net force on the body is equal to 0. The net force on the body is equal to 0 because body is floating. It is in equilibrium. But what are the forces acting on the body? Obviously, there will be weight of the body, right? How do you write weight of the body? You write it as the average density of the body into total volume of the body into acceleration due to gravity. है ना? And I think this will become 750. Total volume of the body is 1 by 1 by 1. That is 1 meter cube into g. So weight of the body is 750 g. Obviously, pressure forces are acting on the body, which will be called as buoyant force. But buoyant force is equal to weight of fluid displaced by the body. I think this is the fluid displaced by the body, है ना? इतना fluid जो है body ने displace किया, right? And obviously this is also in form of a cuboid. ये किसकी form में आएगा? Cuboid की form में आएगा. The volume of liquid displaced by the body will be a cuboid. Now this height will be 1 meter and this height will also be 1 meter. This width is also 1 meter. But the question is, what is the length of the displaced water? What is the height of the displaced water? So let me call this as h. What I will call it as h. So I think when I will talk of the volume of displaced fluid, that will become h into 1 meter into 1 meter. So that will become h into 1, that is h meter cube. Now how do you write buoyant force? So you write buoyant force as weight of fluid displaced. That will be the density of the liquid into volume of liquid displaced into acceleration due to gravity. Now, if I write down the density of liquid, that is 800 kg per meter cube. If I write down the volume of the displaced liquid, that is h meter cube into g. Now, the body is in equilibrium. Therefore, the buoyant force on the body is equal to weight of the body. So, 800 h into g is equal to 750 g. So, you will get the value of h, which is the height of the body inside water. So, g and g will cancel out. H value will be equal to 750 by 800. How much it will be equal to? 750 by 800. So, guys, I think I have not brought my calculator over here. So let me use the calculator of my PC. Okay. So 750 divided by 800. So actually it's 15 by 16. Na? So let me get it from calculator. 0.9375. 0.9375. So height of the liquid, height of the body inside the water, that is 0.9375 meters, right? This is the height of body inside water. So second question also solved. What is solved? Second question also solved. So for second question, the answer is 0.9375 meters. Now the next question is कि भैया, if I give body a vertical displacement, a small vertical disturbance, is the body stable or not? What is my question? If I give a body a small vertical displacement, is the body stable or not? Okay. So I think I will answer myself. So if the body is given vertical displacement, is the body stable or not? So guys, it's very easy. It's very easy. You know what? Right now, the body is in equilibrium. So let me draw the equilibrium condition. Right now, the body is in equilibrium. And this is the equilibrium position of the body. Okay. And this is the volume of fluid displaced. Volume of fluid displaced. Right. Now, what you will say? You will say, in the current scenario, the buoyant force is equal to weight of the body. Buoyant force is equal to weight of the body. This is the current scenario. Buoyant force is equal to weight of the body. And how do you write buoyant force? It is written as density of fluid into volume of displaced fluid into acceleration due to gravity. So this is the weight of the body, right? Now what you do, you give a small displacement to the body in downward direction. and then release the body. So actually right now the body is in this position. The body is slightly downwards in this position. है ना? Now check. Now check the volume of displaced fluid. I think volume of displaced fluid will be this much. Volume of displaced fluid will be this much. And I think the volume of displaced fluid has increased. Volume of displaced fluid has increased. Initially, the buoyant force was equal to weight. But now the volume of displaced fluid has increased because the body has gone down a little. If the volume of displaced fluid has increased, the buoyant force will also increase. Now initially the buoyant force and weight were equal. Whether you take the body down or you take the body up, the weight of the body will remain constant. So initially these two were equal. Now this value has increased. So what will happen? Buoyant force will become greater than weight. So now what will happen? On the body, the buoyant force is acting in the upward direction, which is greater than weight. So buoyant force minus weight, there will be a net force that will push the body back up. So when you displace the body downwards, the buoyant force becomes greater than weight and it pushes the body back up. Similarly, if you take the body out, the volume of displaced fluid that decreases, buoyant force decreases, weight becomes greater than buoyant force, so it will bring the body back. So when you guys are talking of vertical disturbances, vertical displacements, the body is in stable condition, because if you will push the body a little down, the body will tend to come back. If you will pull the body out, the body will fall down. Will try to fall down. So it is in stable condition, restoration capabilities. So I think this we have discussed in our classes also, that when we talk of vertical disturbances, the body is in stable condition. What condition? Stable condition. So your answer is stable condition, right? Stable condition. Okay. Now the next question is, so if I give a vertical displacement to the body and release it, the body will try to come back. But because of inertia, it will cross the equilibrium position, then it will again fall down. So it will start oscillating about the mean position. This is what is going to happen. So if you take a pendulum from the equilibrium position and release it, the pendulum will go like this. So they are asking you, what will be the time period of oscillation? क्या पूछ रहे हैं? अगर vertical displacement देके छोड़ दिया, then what is going to be the time period of oscillation? Hi Tejeshwar, how are you? So Tejeshwar, just for your information, so my concept through questions, that is like daily only. It will go on daily basis. So yesterday it did not happen. Even I was not aware that on New Year there is no class. Okay. So last time we did buoyancy. So through Falkirk wheel. So today we are discussing a question of stability. Tomorrow we will discuss liquids and relative equilibrium. Day after tomorrow, first topic of fluid kinematics. So on daily basis, 1 hour topic, right? Okay. So just for your information, so this is where I started. So my first question was, if this object is dropped in oil, whether the object will float or sink. Second question was, if the object will float, how much is the height of the body inside the oil? Then my next question was, for the same object, if we give it a little vertical displacement, whether the object is stable or not. So answer is stable. Now the next question is, if we give the vertical displacement and release it, what is the natural frequency of oscillation? What is the natural time period of oscillation? So this is the next question. So what we have, next question is natural frequency of oscillation, natural frequency. So you can find out frequency or time period also. You can find out frequency or time period also. Time period also for oscillation due to vertical disturbances. Oscillation due to vertical disturbances. So vertical disturbances like tides, like tides. So tides result in vertical disturbances, vertical displacements, oscillations of the ship. So natural frequency for oscillation due to vertical disturbances. Vertical disturbances. Okay. I think such kind of questions we have already done. So if you will see my fluid dynamics topic, or you will see buoyancy, so I have shown certain kind of questions where there is an oscillating situation. So I have even discussed in those problems how to apply Bernoulli's equation for unsteady state flow. So मैंने वो भी एक case discuss किया हुआ है. So let's see the equilibrium position first. So I hope you remember, in theory of machines, you have learned vibrations, that is oscillations. है ना? So same concept we will discuss here also. So I think you can hear the noise of the train. Actually, I'm living in railway colony right now for a few days. So some days. So it's quite near to the railway platform. And the best part is this house is actually a heritage house. So it's like 900. It was built in 1911. So 1911, I think almost now it's like 110 years old. Okay. So this object was floating. The lower portion of the object, it was made of 1500 kg per meter cube. The upper portion of the object was made of 500 kg per meter cube, and we found out the average density, which was 750 kg per meter cube. We also found out that currently in equilibrium position, the height of the object inside water, that is 0.9375 meters. Okay, this is the equilibrium position. Now guys, let me do one thing. Let me take this as the surface of water, and actually surface of water is constant. For us, surface of water is constant. And let me mark a point on the block which is A. So right now, block A is at the surface of the water. It is at the same plane. Actually, this plane is called as water plane. What is this called as? Water plane. So basically what happens, if this is an object, maybe say for example, ship. So if you consider a ship, the ship will look like this. The ship is going to look like this, something like this. And this is how a boat looks like. So let us suppose this is the level of water. So this plane, that is the intersection of the object and the surface of water. So this plane is actually called as water plane. What is this called as? Water plane. Okay, so I am talking of water plane. So there is a point on the block at the water plane which is A. And right now the body is in equilibrium condition. So I think what you are going to say, you will say the buoyant force on the body is going to balance the weight of the body. This is the equilibrium condition. So you will say the weight of the body is equal to buoyant force, that is the density of fluid into volume of displaced fluid into acceleration due to gravity. And how much is the volume of displaced fluid? So this we have written earlier also. So displaced fluid, displaced water will be a cuboid like this. Height of displaced water is h meters. The length and the width of displaced water is 1 meter. So this volume will be h meter cube. So this volume is h meter cube into g. So this is the equilibrium condition. This is which condition? Equilibrium condition. Now let me do one thing. Let me mark this direction as positive y, and obviously this will become negative y. So any force which is upwards, that is positive. Any force which is downwards, that is negative. Any displacement which is upwards, that is positive. Any displacement which is downwards, that is negative. Now let us pull the object a little out and drop it. So what will happen? The body is in stable equilibrium. So body will start oscillating. So at a particular instant of time, this is the position of the object. At a particular instant of time, this is the position of the object. So basically, A point does not lie at water plane, that is y equal to 0. A point will be somewhere here. So displacement of A point will be y. Please note, A point is a point on the block. Hello Anish, how are you beta? And I hope yours and Tejeshwar's New Year was good. So actually yesterday I did not knew that there is no class. So I was waiting up to 9 o'clock. And when I checked, there was no thumbnail. Then I checked the sheet and I saw that there is no class for planned. So then I realized class was not there. But for your information, only on Wednesdays the class will not happen and on alternate Tuesdays. Otherwise, every day the class will happen and we will discuss one question through concept. So since you have joined just now, so let me show you. So the first question was, there is an object of non-uniform density. I wanted to check whether the object will float or sink. So we found out the average density, which is 750 kg per meter cube. So we realized the object will float. Then we found out how much is the height of the body inside water. So we found it out, 0.9375 meters. So if the body is floating, it will be in equilibrium. Then I asked, if I give a small displacement to the body, whether the body will be stable or unstable. So we know if we push the body a little down, the buoyant force will increase and it will trend to bring the body back upwards. So when a body tries to come back to the initial equilibrium position, that is called as stable equilibrium. है ना? And we proved it that the body is in stable equilibrium. Now we are finding out that if the body is in stable equilibrium, so when you will push the body down and release, or if you will pull the body up and release, there will be some oscillation. Obviously, there will be damping in the oscillation, but if there is no damping, what is the natural frequency of oscillation? So we are finding out the natural frequency. So if you know the concept, very well and good. Don't worry at all. You can just solve the question. But if you do not know the concept, you can let me know. I have made some videos also. So there were like different kind of videos. So there were two types of oscillation. One oscillation was based on Bernoulli's equation in unsteady state flow also. ठीक है ना? तो मैंने 2-3 तरह के oscillations वाले क्वेश्चन कराए हुए हैं. तो एक बार मुझे बता देना अगर आपको सारी टाइप्स पता है. यहाँ पे बर्नौलीज इक्वेशन वगैरह लगाने की जरूरत नहीं है और उसका रीजन है कुछ जो मैं अभी डिस्कस नहीं कर रहा हूं. ये तो सिंपल ब्यूएंसी से हो जाएगा. सो हम थ्योरी ऑफ मशीन वाला ही कॉन्सेप्ट यूज कर रहे हैं जो आप वाइब्रेशन में यूज करते हैं. सो गाइज वेयर आई वाज, हाँ. So now the point A is at Y position. This means the height of object, this means the depth of object inside water is only H minus Y. The depth of the object inside water is only H minus Y. अरे कोई बात नहीं, मैंने वो क्वेश्चन भी कराया हुआ है. सो मैंने ना कुछ दिन पहले फ्लूइड डायनेमिक्स जब चैप्टर कराया था तो मैंने बर्नौलीज इक्वेशन इन अनस्टेडी स्टेट इफेक्ट्स कराया था. उसमें मैंने 5-6 तरह के क्वेश्चंस कराए हैं. तो अगर आप वो क्वेश्चंस देख लेंगे ना, आपका कुछ भी नहीं छूटेगा. उसमें मैंने गेट से ऊपर के ही क्वेश्चन कराए हैं. ठीक है, बर्नौलीज इक्वेशन इन अनस्टेडी स्टेट फ्लो. बर्नौलीज इक्वेशन को आप स्टेडी स्टेट फ्लो में लगाते हैं, अनस्टेडी स्टेट फ्लो में नहीं लगा सकते, है ना. तो अनस्टेडी स्टेट फ्लो में बर्नौलीज इक्वेशन को कैसे लगाना है वो मैंने सिखाया हुआ है. और ये चीज कई बुक्स में भी गलत मिलेगी. सोम साहब की किताब में बहुत बढ़िया दे रखा है, मनसून एंड यंग में बहुत बड़ा दे रखा है, मगर डीएस कुमार में गलतियां हैं और आर.के. राजपूत में गलतियां हैं. वो है ना क्वेश्चन, एम्प्टी ऑफ टैंक, इन व्हाट टाइम द टैंक विल गेट एम्प्टी. अरे भैया उसमें बर्नौलीज इक्वेशन डायरेक्ट कैसे लग जाएगी जबकि हमने डायरेक्ट लगाई हुई है. तो आप डायरेक्ट नहीं लगा सकते. तो अगर प्रॉब्लम आएगा ना, डू लेट मी नो. ठीक है, ओके. मैं कहां पे था? हाँ. सो राइट नाउ द डेप्थ ऑफ बॉडी इनसाइड वाटर इज ओनली H minus Y. So at the current time instant, what will be the buoyant force? At the current time instant, the buoyant force will be the density of liquid into volume of displaced fluid, which will be H minus Y into 1 into G. है ना? This will be the buoyant force. So buoyant force will be rho L H minus Y into G. And obviously there is weight of the body in downward direction. So what you will say buoyant force minus weight of the body is equal to mass into acceleration. and you will write rho L H minus Y G minus W is equal to MA. So I think what you will have rho L H G minus rho L Y G minus W is equal to MA. But please note, in equilibrium condition, when the depth of the body inside water was h, it was equal to weight of the body, right? So what you are left with? You are left with minus density of liquid Yg is equal to Ma. And obviously you can write Ma plus rho Lyg equal to 0. But what is A? A is the double derivative of position. So md square y by dt square plus rho Lyg. अब थोड़ा सा अपना याद करना simple harmonic motion in your vibration chapter. So I think what will happen? You will write the equation like this: d square y by dt square plus rho Lg y upon m, है ना? This is what you are going to write, equal to 0. So I think d square x by dt square plus omega square x. So this is the natural angular frequency of oscillation. What is this? Natural angular frequency of oscillation. That will be rho Lg by m. So natural frequency of oscillation will be under root rho Lg by m. And the time period of oscillation will be 2 pi by omega n. That will be 2 pi under root m by rho Lg. Correct? Yes or no, guys? Please do let me know. Yes or no? If this is correct or not, please एक बार जरूर check कर लीजिए correct है या नहीं है. Okay. Now this is correct. Good, guys. Just a second. Let me check. I hope the units are correct. So rho Ly, rho Lg and m. So this is kg, this is kg per meter cube, and this is meter per second square. So meter square per second square. So if we take an under root, guys, just a second. Acha, 1 into 1. No, this is correct only. This is correct only because the units got adjusted earlier. ठीक है. Actually, guys, one thing I forgot, that here I have 1 meter into 1 meter also. So those units were also there. Okay. So units got adjusted very well. So what we have the time period of oscillation. And yes, using D'Alembert's principle. And if you want to write down the frequency in hertz, that will be 1 by time period. Now, how much will be the numerical value of time period? So 2 pi into mass. Now, density of object is 750 kg per meter cube and the volume of object is 1 meter cube. So, mass of the object is 750 kg. Density of liquid is 800 and G value, let us take it as 9.81. So, when you will find out the oscillation, again I will have to use my calculator. So, let me check. So, 750 divided by 800, this is equal to divided by 9.81 and under root and multiplied by 2 multiplied by 3.1416. ठीक है. So I am getting something like, I think 1.942 seconds. 1.942 seconds. So this is how you find out the time period of vertical oscillation. Is that clear to all of you? All of you, please do let me know. So, वैसे तो I think only Anish and Tejeshwar are watching the video. So, Anish, Tejeshwar, please do let me know if this is clear or not. And then we will move on to the next part of the same question. Please check and do let me know. So, which part is this? I think this is part number 5. ठीक है, very good. Now, in part number 5, I want you to check whether the body is stable or unstable in case of rotational disturbances. Whether the body is stable or unstable in case of rotational disturbances. So if you are unaware of the concept, so I have made a video of stability. It is there on YouTube also. So in the video, first of all, I explained what is the concept of stability. So I took the same example which is there in books, that there is a ball in a bowl. There is a ball on a hill. What is stable equilibrium? What is unstable equilibrium? And then I proved with a toy that if there is a balloon filled toy which has punch me on its nose, so when you hit the toy will go down and come back. So there I have proved that the relative position of the forces will decide whether the body will be in stable or unstable or neutral equilibrium. Then I proved that ships are always in stable equilibrium for vertical displacements. Submarines are always in neutral equilibrium for vertical displacements if you consider the density of water to be constant. Both ships and submarines, they are neutral for horizontal disturbances. But when we are talking of rotational disturbances, these bodies can be stable as well as unstable. But to check whether the bodies are stable or unstable, you will require certain points. What are those points? Those points are center of buoyancy and center of gravity in case of submarines and hot air balloons. And if you are talking of ships, then you also need to check one more point, that is the meta center. So जब भी आप किसी चीज का stability check करते हैं तो आपको ये points की जरूरत पड़ती है. So when we are talking of submerged bodies, if the center of buoyancy of the body is above G, the body is stable. And if the center of buoyancy of the body is below G, the body is unstable. अगर आपको ये concept नहीं पता कि ये कैसे derive होगा, then please do let me know. I will help you out. But here we are not talking of a completely submerged body. Completely submerged body means which is surrounded by a fluid from all the sides, like submarine, like hot air balloon, है ना? So we are not talking of this. We are talking of floating body. In our case, we have a floating body. And this floating body, the lower portion of the floating body, it is made of 1500 kg per meter cube. 1500 kg per meter cube. So this 1/4 meters, this is made of 1500 kg per meter cube. And the upper 3/4 meters, this is made of 500 kg per meter cube. And what is the depth of the body inside water? That is 0.9375 meters. है ना? So to check whether the body is in rotational or whether the body is stable in rotational disturbance or not, we need to find out certain points. What are those points? Those points are center of buoyancy, center of gravity, and meta center. If B is above G, then the floating body is always stable. If B is below G, then the floating body can be stable as well as unstable. The body will be stable if the meta center lies above G, and it will be unstable if meta center lies below G. I hope you remember these conditions. I hope आपको ये condition याद है. क्यों? देखो, submerged bodies में तो बहुत clear है. If B above G and B below G, it will be stable or unstable. Why? What is the reason for that? The reason for that is कि sir, when we are talking of a submerged body, so submerged body means a submarine or anything. Okay. Now, even if the body gets tilted a little, the shape of body is same. The shape of fluid displaced is same. So when we talk of center of buoyancy and the center of gravity, their relative position with respect to the body remains same. है ना? जब आप एक completely submerged body की बात करते हैं, जैसे submarine की बात करते हैं, अगर वो body tilt भी हो जाए, तो इस tilting को ना एंगल ऑफ हील कहते हैं. क्या कहते हैं? एंगल ऑफ हील. दिस टिल्ट एंगल इज कॉल्ड एज एंगल ऑफ हील. So even if the body tilts, the shape of the displaced fluid will remain the same. So position of center of gravity will remain same with respect to the body. But when we are talking of floating body, the initial shape of the displaced fluid is this. But when the body gets tilted a little, the shape of displaced fluid will change. As a result, the center of buoyancy shifts with respect to the body. That's why there are two conditions over here in the second case. तो जब भी आपके पास सेकंड केस आता है तो आपको मेटा सेंटर चेक करना पड़ता है, और अगर पहला केस आ जाए तब तो डायरेक्ट आंसर है स्टेबल. इफ वी हैव द फर्स्ट केस देन वी हैव आवर डायरेक्ट आंसर स्टेबल. इफ वी हैव सेकंड केस देन वी नीड टू चेक द मेटा सेंटर. सो फर्स्ट ऑफ ऑल लेट अस आइडेंटिफाई वेयर इज सेंटर ऑफ buoyancy, वेयर इज सेंटर ऑफ ग्रेविटी. ठीक है. सो फर्स्टली लेट मी आइडेंटिफाई सेंटर ऑफ buoyancy. Now, as per the definition of center of buoyancy is the center of gravity of displaced fluid. Center of buoyancy is the center of gravity of displaced fluid. है ना? Now, displaced fluid is a cuboid whose height is 0.9375 meters, right? So I think the center of gravity of the displaced fluid will be in the middle. That will be at a height of 0.9375 meters from the base. So if you will do half of this, you will have 0.46875. This is the height of the center of gravity of displaced fluid from the base of the body. The center of gravity of displaced fluid is called center of buoyancy. So let me take it as 0.47 meters only. This is like 0.47 meters from the base. Now let us find out the center of gravity of the body also. Now we will find out the center of gravity of body also. So please don't say that, sir, the total height of the body is 1 meter. So center of gravity will lie in the middle. That is 0.5 meter. I will say this is wrong. Why this is wrong? Because the body is not made of uniform density. The lower portion of the body has higher density. The upper portion of the body has lower density. So what will happen? The center of gravity will shift a little, right? Now check. If I consider the lower part, so for the lower part, the center of gravity will lie in the middle. That is 1/4 from the bottom. So 1/8 meters. If I consider the upper part, the center of gravity will lie in the middle. That is half of 3/4. So 3/8 meters. And from here, this will become 3/8 plus 1/4. That is 5/8 meters. Now what I will do? I will apply the rule. M1y1 is equal to plus M2y2 upon M1 plus M2. This will give me the center of mass or center of gravity of the body. है ना? So let us find out y bar. So what is the mass of upper portion? So lower portion. So mass of lower portion is 1500 into 1/4. So lower portion, the volume is 1/4 meter cube into y1, which is 1/8. Upper portion, what is the density? 500. What is the volume? 3/4 meter cube. We calculated it earlier. And what is y2? It is 5/8 from the base divided by 1500 into 1/4 plus 500 into 3/4. That is the total mass. Now, I think when we will solve this, we will have 1500 plus 1500 into 5, and in the numerator 4 into 8 is common. Then 1500 plus 1500, and in the numerator 4 is common, which will go up, right? And actually M1 plus M2 is nothing but it is the total mass, and M1 plus M2 is the total mass only, that is 750 kg. So you can simply write 1500 plus 7500, that is 9000. 9000 divided by 4 into 8, into 750. And what will happen? I think 750. So let me solve it. Let me solve it. 4. So guys, please do check. Please do check if I'm not making any calculation mistake. Please do check. So this will become 3 by 8. This will become 3 by 8 meters. 3 divided by 8 meters. So how much is 3 divided by 8? So 3 divided by 8. I'm directly taking it as 0.375. 0.375 meters. This will become 0.375 meters. Just a second guys. My computer got hanged. 0.375 meters. 0.375 meters from the bottom. So for this particular body, which is floating, the center of buoyancy of the body is nearly at a height of 0.47 meters from the bottom, and center of gravity is at a height of 0.375 meters from the bottom. So center of buoyancy is above center of gravity. So this body, which is floating body, this body is in stable equilibrium. Which equilibrium? Stable equilibrium, right? So for rotational disturbances, this is in stable equilibrium. But please note, if in case the center of gravity is above the center of buoyancy, which is general case, because if the body is made of uniform density, the center of gravity will lie here, and the displaced fluid, the center of buoyancy will lie here. So if the body is made of uniform density, if a floating body is made of uniform density, the center of buoyancy will lie below center of gravity. So actually the general case is this. So in this case, what we do, we find out a new point, which is the metacenter. So what will happen? The center of gravity will remain here only, which is based on the shape of the body. But center of buoyancy will shift to a new point, that is B dash, है ना? And this point of intersection will be called as metacenter. So what we do, if the metacenter is above G, the body will be stable. If the metacenter is below G, the body will be unstable. So what we do, we define a term GM, that is the metacentric height. क्या define करते हैं? Metacentric height define करते हैं. Metacentric height define करते हैं. So this metacentric height, this is equal to BM minus BG. Now BG can be found out. How? So in the previous question, I found out the position of center of buoyancy. I found out the position of center of gravity. So distance between them is BG. And what do you mean by BM? So BM is actually, this BM is equal to I by V minus I by V. BM is equal to what? I by V. So when you are talking of GM, that will be BM, which is I by V minus BG. Now you will ask me, sir, what is I over here? V we know. V is the total volume of the body. What is I over here? So by the way, this concept has never come in GATE exam. It is not part of GATE exam, but just for your knowledge, I am telling it to you. Okay? So what we have, suppose there is a ship. There is a ship. So maybe the ship looks like this. Let me draw a bigger one. Okay. And this is the level of water. Now the plane of intersection of level of water with the ship, this is called as water plane. What is this called as? Water plane. Now for this cross section, that is the water plane, you find out the centroid. You find out what? Centroid. From the centroid, you draw 3 perpendicular axes. One is along the direction of motion of the ship. One is perpendicular to it but horizontal, and one is perpendicular to it and vertical. The rotation of the body about this axis, this is called as rolling. इसको क्या बोलते हैं? Rolling बोलते हैं. Rotation of the ship about this axis, this is called as pitching. And rotation of the ship about this axis, this is called as yawing. So in case of ships and submarines, this is a result of disturbance. But in case of aeroplanes, we want to achieve this rolling, pitching and yawing in order to move the aeroplane in the other directions, right? So for this we have slats, we have flaps, we have rudder, है so lot of movable parts are there on the wings in case of aeroplanes. But here it is a result of the disturbance, that is the tides, that is the waves, wave action. So what I am saying, if the ship is moving in this direction, so this is called as longitudinal axis. So this is called as rolling. And this will be called as pitching, and this will be called as yawing. Okay. So if you are considering rolling, then I is the moment of inertia of the cross section about longitudinal axis. If you are talking of pitching, then I is the moment of inertia of the cross section, that is the water plane, about 2 axis. ठीक है ना? तो ये आपको इसकी जरूरत नहीं पड़ेगी in GATE exam, but this can come in IAS exam. So if you want more questions on it, you can definitely ask me. Now, generally the ship has much larger length as compared to width. So that is an important factor while comparing rolling and pitching. ठीक है? ऐसा कुछ होता है. Now suppose if GM comes out to be positive, but what is GM is equal to? GM is equal to BM minus BG, है ना? GM is equal to BM minus BG. So if GM is positive, this means BM is greater than BG. So obviously meta center is above G. But if GM is negative, this means BM is less than BG. So a meta center is below G. So if meta center is above G, it is stable. If meta center is below G, it is unstable. And if a floating body is stable, there is a time period of oscillation. Again, this time period of oscillation is not a part of GATE syllabus, but it can be asked in IES. Now this is equal to 2 pi into mass moment of inertia of the entire body. Not area moment of inertia of water plane, but mass moment of inertia of the entire body, divided by weight of the body, and one more thing I am missing. That is GM, metacentric height. That is GM, which is the metacentric height. So ये जो metacentric height का formula है, टाइम पीरियड ऑफ ऑसिलेशन है, रोलिंग, पिचिंग या यॉइंग है, दैट इज नॉट अ पार्ट ऑफ गेट सिलेबस. 30 इयर्स में कभी भी पूछा नहीं गया है, बट इन आईएएस इट कैन बी आस्क्ड. So just for your information, I am telling you, if you want me to solve questions on this, if you want me to derive these formulas, and if you want me to take to you to practical applications of this, then you can definitely ask me and I will do it. Okay? So that's all for today. I will not take more time of yours. In GATE question, what is the question to be asked? So the first 4-5 questions that we have done, first 4 questions. So what were the 4 questions? Body will float or not? What is the height of the body below water? Then whether it is vertically stable, and what is the time period of oscillation, and whether it is rotationally stable. Time period of oscillation for rotational disturbances, values of metacentric height, that is not part of GATE syllabus. And once GATE exam is over, you can check why some ships have U cross section, why some ships have V cross section, what are anti-roll tanks, what are bilge keels, what are fins, rolling stabilizers. So like this, lot of things are there in a ship. Ship design इतना आसान नहीं है. मजेदार चीज तो ये है, when the oil gets consumed, then also the center of gravity of the body is going to shift. So rotational dynamics of body keeps on changing as the ship moves ahead. The passengers on the ship keep on moving. The tankers on the ship keep on moving. I mean the load on the ship. Then also the rotational dynamics of the ship changes a little. ठीक है ना? So ठीक है फिर. That's all. And if you want more discussion like I have done in the theoretical class, so comparing the passenger ships, comparing the defense ships, you can definitely ask me, but this much is sufficient for GATE exam. All the best, or revision karo. Tomorrow we will meet with liquids in relative equilibrium. Thank you. See you in the next class. Thank you so much. Bye bye.